Another question is about the transformation. So first, we have the y equal to cosine x. And then we want to use the graph of this function to get the graph of y equal to cosine of x plus pi over 6. So we know when we try to do the translation, we know we need to translate the graph of the cosine x to the left by pi over 6 unit to get the graph of the y equal to cosine of x plus pi over 6, right? So that means you may just first translate all those 5 key points, and then you get the corresponding new 5 key points on the graph of this function. Then you can get the graph of this function. So for this one, we may have those 5 key points. See here we have the 0, so cosine 0 is equal to 1, so we have the 0, 1. And then half pi, cosine half pi is equal to 0. And then cosine pi is equal to negative 1. Cosine 3 pi over 2 is equal to 0. And then finally, cosine 2 pi is equal to 1. Then how do we get the corresponding 5 key points on this second function? So this time, you may have the value like this. So now, since we need to shift the graph of the y equal to cosine x to the left by pi over 6 units, right? So then you shift 0 to the left by pi over 6, then you get the negative pi over 6. Actually, if you plug in this negative pi over 6 into here, you get the cosine of the negative pi over 6 plus pi over 6. So that is cosine 0. Then cosine 0 is equal to 1, right? Then similarly, you shift the half pi to the left by the pi over 6, you get the half pi minus pi over 6. And this is equal to, okay, 3 pi over 6, 3 pi minus pi, you have 2 pi over 6. That is the pi over 3, right? So in this way, you get the x value, and then corresponding y value is equal to 0. Similarly, you can do for the other 3 points in such a way that you find all those 5 key points for the graph of the second function. So this is some questions we got from last class. So by now, we have been dealing with the sine and cosine function with the period 2 pi. So now we need to investigate some cases in which we change the period of the sine and cosine function. So let's talking about the changing the period. And let's look at one example. And we need to graph one cycle of such a function y equal to sine of half x. And we need to determine the period of this function. So first, we know the basic sine function y equal to sine x completes one cycle for x between the 0 and 2 pi. So now, let's see for what values of x this new function completes its one cycle. So that means this input must be between the 0 and 2 pi, right? So right now, to get the 1 cycle of this function, we set half x greater than or equal to 0 and less than or equal to 2 pi. Now we just multiply each part of this inequality by 2. Then we get 0 less than or equal to x. And then 2 times 2 pi get 4 pi. So that means for this function, it completes 1 cycle for x between the 0 and 4 pi. So now let's draw the rectangular plane. Then you can mark out 0 here and then 4 pi here. Then you get the middle point of the 4 pi, that is 2 pi. Then the middle point between the 0 and the 2 pi, that is pi. And the middle point between the 2 pi and 4 pi, that is 3 pi. Then you can draw the graph of this sine function, right? So actually, one is about here, and then you have the graph like this. Okay, so this is graph of the sine of half x, and from this graph you can see the period is equal to 4 pi. All right. Now let's go to the page 453 and let's look at the one theorem about the period of the sine and cosine function. So if you have the function y equal to sine of bx and the function y equal to the cosine of bx, here b is a positive number, then the period of these two functions is given by this formula, 2 pi divided by the coefficient of the independent variable b. Okay, here b, we need b to be positive. Now let's look at one example to see how we use this theorem to find the period. Suppose we have the function y equal to sine of pi over 6 times x. Then we need to find the period of this function and graph the 2 cycles of these 2 functions. Okay, so find the period and then graph 2 cycles. So first, period p is equal to 2 pi divided by the coefficient of this x. So that is a pi over 6. Right? And to simplify this complex fraction, we multiply both numerator and denominator by 6, so that the 6 and the 6 cancel. Right? So you get 2 pi times 6 over pi. And then this 2 pi's cancel. So finally you get 2 times 6, 12. So the period for this function is equal to 12. Now we can draw the 2 cycles of this sine function. So let's begin with the fundamental cycle. Say this is the 12 and this is the 24. So this is the middle point of the between the 0 and the 12, so 6, right? And then 3 here, and then 9 here. Right. So you can draw the first fundamental cycle in such a way. And then second cycle. in such a way. Okay, so this is just a sketch. So we get the 2 cycles of this function.